scaling stories for the two of them. When we talk about dealing with queries and scaling queries, queries operate with eventual consistency. If you ask me for what the state of customer 1234 is, and I put it on the network for you, if somebody else changes that data right now, do I have like a yo-yo packet on the network that I can pull it back? No, so you're already eventually consistent. We've made this determination. So why don't we just instead talk about how eventually consistent you are? Because I'm sure everybody in this room knows if we give up consistency, we can reach availability and partitionability. Now for reads, that's perfectly okay. For writes, giving up consistency is a real pain to deal with. Doing validation off of eventually consistent data is difficult. But for queries, they're already eventually consistent, so why not embrace that? An example of what we could do is we could put out a series of events. The series of events will go to a denormalizer here, we'll write them into a different data storage. Now, if I need to scale, I multiplex this. I can multiplex this queue to 100 queues, and I can have a denormalizer in a data store listening to the end of each one of those 100 queues. Now, 100 databases producing queries. How many queries per second do you think that'll do? A few? At least 5. The idea here is we can reach near linear scalability on the read side. Now, I say near linear because there's no such thing as linear scalability. I'm sorry, once you get over a certain number of servers, you're no longer scaling in a linear fashion. You have administrative costs, other things that go inside of it. I mean, when you start talking about, I need so much electricity,